Hello all, I'm Siddharth Kaul and I welcome you to Edupedia World. In this video series, I'm going to talk about language fundamentals. There are four basic topics to be covered in language fundamentals. The first is matrices and types of arrays, second is expression, third is indexing, and the fourth is working with commands. So let's start with matrices and types of array. Matrices in Matlab is a very huge topic, so it will be revisited many times in future videos. But for now, I'm going to build upon the previous video and put some new points and summarize the old presented points. In Matlab environment, a matrix is a rectangular array of numbers. Special meaning is sometimes attached to one by one matrix which are called scalars, to the matrix with only one row or column which are called vectors. So basically a scalar is nothing but a matrix with the dimension 1 by 1 and vector is nothing but a matrix having only one row or one column. Matlab has other ways of storing both numerical and non-numeric data, but in the beginning it is usually best to think of everything as a matrix. The operations in Matlabs are designed to be as natural as possible, where other programming language works with numbers at one time. Matlab allows you to work with entire matrices quickly and easily. So basically, instead of doing operation on numbers, we are doing operation on whole of the matrices. For purpose of simplicity, all the creation variants and operation will be demonstrated with help of this magic matrix. Someone with background in mathematics might recognize this matrix as a magic square. If not, it's better that you do a Google search on magic matrix or Dürer matrix. It's a very good read. So as seen in the previous videos of matrices and arrays, we saw a couple of ways to create matrices. First was we enter list of elements and concatenate it using square matrix and create an array. Second, we load matrices from the external data files into our workspace. Third, we used built-in functions to generate matrices like ones and zeros. And fourth, we create our own matrices with the help of our own function and save them in files. So I'm not going to touch on that in this video. Moving on. The part I am going to show in this video has more to do with operation that we perform on matrix and how that operation can be achieved in Matlab. So there are three main operations that can be performed on any matrix. One will be amazed to know that how quickly and easily it can be done in Matlab. Operations on whole set of matrices is what makes Matlab. We'll start with summing operation. Sum of x is built-in function that returns the sum of elements of vector x. If x is a matrix, then the sum is a row vector of sum of elements of each column, as you can see. We'll get back to sum operator in later slide and see how it can be used with other operations. The transpose operation. There are two transpose operators in Matlab. The first one is the apostrophe operator that performs a complex conjugate transposition. What it does is basically it flips a matrix about its main diagonal and also changes the sign of imaginary component of any complex element that may be present in the matrix. The second one is dot apostrophe operator. This transposes without affecting the sign of complex elements. So basically for our matrix, which has all the real numbers, both operation will return with the same result. The diagonal operation. The diagonal built-in function returns the diagonal of the matrix. Though it sounds simple, but it actually can do all other stuff as well. Let's see it in an example. We can use the combination of these operations to return easy solution to cascaded items, such as finding sum of diagonal of a transposed matrix, such as this. This is just one of the examples that I could think out of the top of my head. There are many such things that is used during operations on matrix. Moving on. Before I move on, there is one more thing I like to show. Though it is redundant, already covered, but it is necessary that I discuss this. Using built-in function, there are 4 ways we can generate a matrix. First is using zeros, second is using ones, third is using rand, and fourth is using random normalized. Here is an example to demonstrate generation of matrix using zeros. Here is another example that demonstrates generation of matrix using ones. Here is an example that demonstrates generation of matrix using random function that gives a uniformly distributed random elements. And finally, we have a random normalized function that generates matrices based on normal distribution.
Multidimensional arrays. Multidimensional arrays in Matlab environment are arrays with more than 2 subscripts. One way of creating a multidimensional array is by calling built-in functions such as zeros, ones, random or random normalized with more than 2 arguments. For example, here I called a random normalized with 3, 4, 5. So basically this creates a 3 by 4 matrix 5 times. So here we have a total of 60 elements, 60 normally distributed random elements. It is actually quite difficult to explain multidimensional arrays without any proper visual aid, but here I will give it a try. The following image shows 4 by 4 by 24 array. So it has 24 4 by 4 matrix in one single array. So to access any element in this array, it would require a 3 number subscript to access it. Say for example, if I have to access the 16 in the first element, so I have to call like 1 1 1 and so on. So this is the kind of stuff that we'll be dealing with in indexing. The indexing video will clear all the doubts regarding accessing the multi-dimensional arrays. Now cell arrays. Cell arrays in Matlab are multi-dimensional arrays whose elements are copies of other arrays. A cell array of empty matrices can be created with a cell function, but more often cell arrays are created by enclosing a miscellaneous collection of things in curly braces. The curly braces are also used with subscripts to access the contents of various cells. For example, here I will create a cell array of my matrix. So basically what I am doing, I am taking a variable C. I am creating first element, that is will be my matrix, second will be sum of my matrix, and third will be sum of diagonal of my matrix. This produces a 1 by 3 cell array. The 3 cell contains our matrix, then sum of each column of matrix and sum of diagonal of our matrix. So when C is displayed, something like this is shown. Again, here are 2 important points to remember. First, to retrieve the contents of one of the cells, we use subscripts in curly braces. For example, C of 1 retrieves the matrix, C of 2 retrieves the row vector, that is sum of the matrix, and C of 3 retrieves the sum of diagonal of our matrix. Second point to note is that cell array contains copies of other arrays, not pointers to those arrays. I will repeat. The second cell, the cell arrays, contains copies of other arrays, not pointers to those arrays. So if we do changes in my matrix, nothing will happen to C. That is our variable. Matrices, as said before, is a huge topic. In that too, we have cell arrays that need to be understood to start working properly with character, text and structures. So in the next part of this video, that is the part 2, I am going to look into characters and text as cell arrays, and in the part 3 of this video, we are going to look into structures. So these are quite the exciting stuff coming up. I will take a break here and stop this video, and we'll pick this up in the next video. I will start by a summary of whatever we have seen in this video, then we'll move on to the characters and string. So please check out my blog matlabexamples.wordpress.com that contains summary of all the videos posted in the Edupedia and some other content as well. So do give it a look. Till then, please subscribe, stay tuned to Edupedia World, and thanks for watching.